In space, silence is not unusual. Vacuum does not carry sound. Signals travel as particles and fields, not as noise. What is unusual is when silence begins to respond. Far beyond the orbit of Mars, moving on a trajectory that cuts cleanly through the plane of the solar system, an object is passing that does not belong to our cosmic neighborhood. It was not formed by the Sun. It did not emerge from the same disk of dust and gas that gave rise to the planets. Its chemistry, its radiation history, and its internal structure were shaped under a different star entirely. And yet, for a brief moment in time, it is here. Astronomers have given it a technical name: precise, emotionless, almost forgettable. 3I Atlas. But the measurements associated with this object tell a very different story. As December 19th approached, 3I Atlas entered a region of space where geometry, timing, and instrumentation aligned in a rare way. Not for collision, not for impact, but for observation, a window where weak effects could finally be separated from background noise. As scientists focused their telescopes on this interstellar visitor, something unexpected began to happen elsewhere, around Mars. A spacecraft never intended to study interstellar objects quietly started recording subtle changes. Not dramatic, not alarming, but unusual enough to raise questions that are still being examined. That spacecraft was MAVEN, and what it detected may reshape how we understand interstellar visitors, not as threats, but as physical experiments passing through our solar system. To understand why this matters, we must first understand what 3I Atlas actually is. Humanity has confirmed only 3 interstellar objects in recorded history. The first, Oumuamua, discovered in 2017, puzzled astronomers with its strange acceleration and lack of a visible coma. The second, 2I Borisov, behaved more like a conventional comet, albeit one that originated beyond the Sun's influence. 3I Atlas is the third, but it does not neatly fit into either category. Its velocity is extreme, far higher than objects bound to the Sun. Its trajectory is steep and hyperbolic, leaving no doubt that it is not gravitationally tied to our system. Long before it encountered the heliosphere, it was already moving on a path shaped by another star. That fact alone makes 3I Atlas extraordinary. It is not a hypothesis. It is not speculation. It is physics. This object formed in a different stellar environment, under different radiation pressures, with a different chemical history. In a very real sense, it is a sample of another solar system, one we did not have to travel to collect. December 19th was not important because of danger. It mattered because of alignment. On that date, 3I Atlas reached a position where its interaction with the solar wind intensified, where its relative geometry with Mars and Earth allowed multiple instruments to observe overlapping regions of space, and where faint plasma effects could be measured with higher confidence. Astronomy often depends less on events and more on timing. Windows open briefly, then they close. December 19th was one of those windows. MAVEN, the Mars Atmosphere and Volatile Evolution mission, was never designed to watch comets or interstellar objects. Its purpose is far more specific: to understand how Mars lost most of its atmosphere over billions of years. To do that, MAVEN studies invisible forces: solar wind pressure, charged particle flows, magnetic field distortions, ion escape rates. It observes how Mars reacts when space pushes against it, and that sensitivity is exactly why MAVEN noticed something subtle. As 3I Atlas moved deeper into the inner solar system, MAVEN recorded small but structured variations in the charged particle environment surrounding Mars. These were not random spikes, not instrument errors, not classic solar storms. At first, they were treated as routine fluctuations, but over time, a pattern emerged. The variations aligned, not perfectly, but consistently, with the trajectory and timing of 3I Atlas. This did not suggest danger, and it certainly did not suggest technology. What it suggested was interaction. To understand this, we need to talk about plasma physics. When comets approach the sun, they release gas and dust. Solar radiation ionizes this material, turning it into plasma. That plasma interacts with the solar wind, creating complex structures, tails, waves, and electromagnetic disturbances. But interstellar objects are different. Their material composition may not mirror that of solar system bodies. Their volatile content, dust grain structure, and ionization behavior may fall outside the parameters our models were built around. If 3I Atlas was shedding material, however faintly, that interacted with the solar wind in an unfamiliar way, the effects might not be visible near the object itself. But they would propagate, and Mars would feel them. Unlike Earth, Mars lacks a global magnetic field. It is exposed, vulnerable, reactive. Its atmosphere directly interacts with the solar wind, making it an extremely sensitive detector of changes in the surrounding plasma environment. In this sense, Mars functions like an antenna, and MAVEN is its recorder. What MAVEN detected was not the object itself, but Mars responding to changes in space around it. Slight shifts in ion escape rates, small distortions in pickup ion distributions, temporary variations that did not match solar-only models. Importantly, many of these effects diminished after 3I Atlas passed through the observational window. That detail matters. Permanent disturbances can be dismissed as system drift or background noise. Temporary, repeatable changes suggest cause and effect. This is the secret often misunderstood in public discussions. There is no evidence of propulsion, no artificial emissions, no intelligent control. The revelation is far more subtle and far more valuable scientifically. Interstellar objects may interact with planetary environments differently than native solar system bodies. That means our models, built almost entirely on local examples, may be incomplete. This is not a failure of science, it is how science progresses. So why wasn't this announced loudly? Because science does not shout when uncertainty remains. NASA does not declare discoveries based on early correlations. Data must be cross-checked, peer-reviewed, and compared against every plausible alternative explanation. That process is slow, and intentionally so. In an age of instant conclusions, restraint is a strength. It is also important to separate reality from myth. There is no evidence that 3I Atlas is artificial, no indication of intelligence, no threat scenario, no interception, no countdown. What is real is that we are observing an interstellar object during an era of unprecedented instrumentation. Multiple missions, multiple datasets, multiple perspectives. This has never happened before. After December 19th passed, attention did not fade. It intensified. Scientists began comparing conditions before, during, and after the alignment. Some measurements returned to baseline. Others revealed correlations that are still being analyzed. This introduces a new concept in space science. Space weather has traditionally focused on the sun, solar flares, coronal mass ejections, and particle streams. But interstellar objects introduce external material into the heliosphere at extreme velocities. That material does not share the sun's history. When ionized, it behaves differently. This is not speculation. It is physics observed in laboratories, now scaled to astronomical proportions. Some have asked why Earth did not notice these effects as clearly. The answer is simple. Earth is shielded. A strong magnetic field, a thick atmosphere, layers of protection that dampen subtle plasma variations. Mars has none of these defenses. Earth is armored. Mars is exposed. And that exposure makes Mars invaluable as a scientific instrument. Interstellar objects are often treated as curiosities, rare visitors that pass and are forgotten. But 3I Atlas challenges that view. These objects are not just rocks, they are samples, they are probes, they are test particles moving through our system under known physical laws. They allow us to study how non-native matter behaves under solar conditions without launching a single spacecraft. That is experimental astrophysics on a cosmic scale. Scientists are careful with their language because extraordinary claims require extraordinary evidence. So far, the evidence points toward natural processes, but natural does not mean trivial. Natural means governed by laws. Laws we are still learning. 3I Atlas will not be the last interstellar visitor. Based on current estimates, such objects pass through the solar system far more often than we detect. We are only now becoming sensitive enough to notice them. Future missions may track them earlier, analyze their plasma signatures directly, and perhaps even sample their material remotely. What 3I Atlas provided was not answers, it provided calibration. It reminded us that the solar system is not isolated, that interstellar space is not empty, that stars exchange material and galaxies recycle matter continuously. Every interstellar visitor carries information, not messages, not intent, but data about environments we cannot reach. December 19th was not a countdown. It was not a warning. It was not an ending. It was the beginning of a new way of observing, one where planets act as sensors, where spacecraft detect indirect effects, where interstellar objects quietly test our understanding of physics. 3I Atlas passed without spectacle, no explosion, no visible drama in the sky. And yet, something important happened. Because the universe does not announce its lessons, it leaves traces, and only those patient enough to listen ever hear them.